Hi, my name is Brian Raymond.
My name is Mitri Bondara.
My name is Miriam Alvarez.
And I'm Thomas McKean.
And we're here to tell you about R.G. Rocha's study, Independent Reversals to Terrestriality in Squirrels Support Ecologically Mediated Modes of Adaptation.
The family Squirrelidae is a family that comprises of many medium-sized rodents such as the squirrel and is an extremely ecologically diverse family. Rodents of the Squirrelidae family can be found all over the world, which makes them a good basis for investigating the relationship between locomotion modes, which is the movement of an organism from one geographic location to another, and biogeography of animals, which is the geographical scattering of the species. The squirrel is an ideal example of the ecological worldwide distribution of the Squirrelidae family. They have undertaken evolutionary modifications on all the continents, with the exceptions of Antarctica and Australia, and are the second most assorted monophyletic group of rodents with 285 different species and 51 genera in their clade.
Squirrels are also very widespread in terms of locomotion, making comparisons between habitat and movement easier to study. There are terrestrial species who live and nest on the ground, arboreal species, which live and nest in trees, intermediate species that live and nest on the ground but are adept climbers, and gliding species that are able to glide between trees. The goal of the study is to understand the relationship between locomotion modes of squirrels and the biogeography of squirrels due to these locomotion changes. Researching locomotion and other lifestyle changes in an ecologically widespread species, such as the squirrel, along with biogeographic analysis, is very beneficial for comprehending how and why mammals adapt. It tells us whether changes in a mammal's lifestyle, specifically locomotion, are associated with adaptation towards geographical locations or towards biogeographical transitions.
The study collected data on 184 species in the Squirrelidae family and classified them according to their method of locomotion and the landmass each species lives on. The four categories of locomotion Rocha and others utilized are arboreal, terrestrial, intermediate, and gliders. Each species was also assigned to one or more of four land masses: Eurasia, Africa, North and Central America, and South America.
From these baselines, the team analyzed several evolutionary models and weighted them based on each study's posterior probability, its likelihood of being true based on current observations, to determine the most probable evolutionary tree of the Squirrelidae family back to a single common ancestor. Dispersal vicariance analysis, which is the analysis of the geographical spread of the population, was employed to track the spread of squirrel species across the globe, with 4 events allowed to occur at cladogenesis, or the specific point of evolution from one species to another. These 4 events are: 1. The ancestral range is copied to both species. 2. The new species are separated geographically. 3. The new species evolves in only a subset of the ancestral range. And 4. The new species emerges in a range outside the ancestral range. Furthermore, these are not mutually exclusive events. These results were then weighted by probability to generate the migratory and evolutionary trees.
The team concluded that the most recent common ancestor was an arboreal species. From this ancestor, gliding evolved once, and a reversal to terrestriality occurred independently 4 times. It was also concluded that this MRCA originated on the continent of Eurasia rather than North America, as was previously assumed from the fossil record. The researchers doubt that the existing theories of the American origin of squirrels are valid, because the teeth were the only part left of the organisms found in North America that is considered to be ancestor of the modern squirrel. It is possible that these teeth may be from another species entirely.
Rocha then proposed an alternative hypothesis, according to which squirrels originated in Eurasia. This speculation is supported by the fact that the diversity of squirrels on this continent is the greatest, which may imply that this part of the world was the starting point of arboreal Squirrelidae. Although it is generally thought that squirrels have undergone this change independently on different continents, the researchers proposed that all the species with different lifestyles originated in Eurasia, before spreading out onto other continents, since the reversal to terrestriality and the evolution of gliding might be the results of tense competition within the arboreal species. This might explain why squirrels that lead each of the 3 lifestyles coexist on all continents.
The researchers also generally confirmed the existing theory that squirrels originated as an arboreal species, since the divergence from all the other rodents, which are terrestrial organisms, could have happened as a result of the evolutionary advantages that accompany an arboreal lifestyle, such as a decrease in the amount of predators and the likelihood of disease. This would have been instrumental to the formation of the prezygotic reproductive barriers that have helped squirrels to form as a separate taxon. Squirrels' origin is an illustration of the fact that sometimes archaeological evidence might contradict with the data derived from empirical data, but that is the nature of science, to study, experiment, and learn.
Thanks for watching!